Welcome you to my YouTube channel. In this video, I'm going to discuss very important questions in Nernst Equation. You will learn how to calculate E cell value and the delta G naught. The second one, how to calculate E naught cell value. The third question, I will be discussing how will you calculate electric potential of a given metal. Calculate EMF and delta G for the following cell. Here, cell representation is given. Here, E naught value for Mg plus 2 to Mg is given, and E naught value for Cu plus 2 to Cu is given. You are asked to find out EMF of the cell. This cell is not operated at standard condition. The output is going to be different. To find the actual output, we are going to employ Nernst equation. So what's the Nernst equation? Nernst equation is E cell is equal to P naught cell minus 0.0591 divided by N into log Q. Here, to find out E cell value, you need to know E naught cell, you need to know N, as well as you need to know Q. E naught cell is nothing but standard EMF of the cell. N refers how many number of moles of electron transferred, and Q refers reaction quotient. How to find out E naught cell? So formula is E naught cathode minus E naught anode. You need to first know what is anode, what is cathode. What is given? Cell representation is given. It is of this form: anode, salt bridge, cathode. So here, left hand side I have anode, right hand side I have cathode. In short, you can remember this as ABC. A refers anode, B refers salt bridge, C refers cathode. Mg is converted to Mg plus 2. So increase in oxidation state indicates oxidation taking place. Look at this. Here in anode, Mg gets converted to Mg plus 2, right? At cathode, copper plus 2 converted to copper. So remember this one. Here I have Mg plus 2 to Mg, the value is given here. Copper plus 2 to copper, the value is given here. Got it? So here, now I found what is my cathode. So this is my cathode value minus anode value. Cathode value here is 0.34 minus anode value here is minus 2.37 volt. So minus and minus would become plus. So if this cell is operated at a standard condition, the actual output of the cell will be 2.71. But the concentration of Mg plus 2 and the Cu plus 2, since it is different, the output is going to be different. As I mentioned before, this is my anode, this is my cathode. So let's now write what reaction is taking place at cathode. So at cathode, copper plus 2 converted to copper. At cathode, reduction reaction taking place. What is reduction? Gaining of electron. So here copper plus 2 converted to copper. For this conversion, 2 electrons are required. So this reaction associated with 0.34 volt. At anode, oxidation reaction taking place. Here, Mg converted to Mg plus 2. This would happen when 2 electrons are lost. If you want to write net cell, what you have to do? You have to cancel it out. Check whether the number of electron gained is equal to number of electron lost. Yes, it is right. So I can simply add these two equations. So here I have on the left hand side copper plus 2. I can write it. Here I have Mg. Here I can write it. And then on the product side I have copper. So copper I have written. Here I have Mg plus 2. Mg plus 2 I have written. So this is how I can write net reaction. You may have the question why we are writing net reaction. So this is written because to find out Q value. Got it? So to write Q value, I need to know what are the products we have and what are the reactants we have. So here the products are Mg plus 2 and copper, and the reactants are copper plus 2 and Mg. So if you want to write the concentration terms for this, since this copper and Mg are solid in state for which the activity is going to be considered as 1. Got it? So I'm going to have in the place of copper and the place of Mg is going to have 1. And look at this reaction. The number of electron involved here is 2. I hope you understood. So here I have found the value of N, and then I'm going to find the value of Q. The concentration of Mg plus 2 is given. It is 0.001. Concentration of copper plus 2 is given. Here 0.001. If I simplify this, I will be getting 10. If you have the question, you can simplify very easily if you write it in terms of 10 powers. So here you have decimal place. this point, if it is moved towards right side, you should have minus. How many places I'm moving? Three places I'm moving. It has to be brought after the first non-zero digit divided by. Here I have decimal place here. 1, 2, 3, 4. So 10 power minus 4. So if I simplify this, 10 power minus 3 into 10 power 4. So if I simplify this, I will be getting 10. So I have to add the powers. If I add the power, I will be getting value 10. Right. So now I have to substitute all the value I have got. I found E naught value, and we found what is the n value and what is q value. So see, log 10 value is 1. Log 10 value is 1. I'm going to now simplify it. So if I simplify this, I will be getting this answer. So if I subtract 0.0296 from 2.71, I will be getting output of this cell. So I have found EMF of this cell. Still, what should I now find? I have to find delta G for this cell. So what's the formula to calculate delta G? The formula is minus NF E cell. What are things required for finding delta G? I need to find N value, I need to know F, I need to know E cell. For this question, we already know all these things. We know how many number of electrons involved, and we know the Faraday value. It is constant 96,485, or it can be approximated as 96,500. And E cell value just now we found 2.6804. What I have to do, I have to simply substitute all values here. Then I will be getting answer in joule per mole. And if this joule per mole has to be converted to kilojoule per mole, I will be getting answer for delta G. Remember, for the reaction to be spontaneous, E cell value should be positive, delta G value should be negative. Let's go to the next question. Calculate E naught cell for the following reaction at 298 Kelvin. Here, net reaction is given 2Al plus 3Cu plus 2 gives 2Al plus 3 plus 3C. For this, E cell value is given. So you are asked to find what is E naught cell value, which means if this cell operated at a standard condition, what would be the output I need to find? So here, first thing what should you do is what is acting as anode, what is acting as cathode. At anode, oxidation reaction taking place, which means that oxidation number increases. Here you see aluminum, you have oxidation number as 0. Here oxidation number is plus 3. 0 converted to plus 3. At cathode, reduction reaction taking place. So reduction means oxidation number should decrease. See, copper plus 2 converted to copper. For this conversion, it requires 2 electrons. Always loss of electron should be equal to gain of electron. But in this case, 3 electrons are lost by Al, whereas 2 electrons are required for copper plus 2 to be converted to copper. Here I have number 3, here I have number 2. I have to make it equal. How I can make 3 to be equal to 2? So multiplying this 3 with the 2, multiplying this 2 with 3. So that I will make it the number of electron loss to be equal to gain. So that is why I have chosen the suitable integer to multiply. So after this, I'm going to add these two reactions to get the net reaction. Got it? Okay, so if I write it, I can cancel it out. You can also find the number of electron by this way. Let me tell you a short trick to find out. So here you have 0, here also you have 0. If these two numbers, here I have plus 2, here I have plus 3. If these two numbers are same, we can use the number as it is. If it is not same, you can simply multiply these two numbers to find out how many number of electrons are involved. So here what I found, the number of electrons involved here is 6. You can either use short trick to find out the number of electron, or you can write the half cell reaction to find the number of electron involved. The Nernst equation is cell value E naught cell minus 0.0591 divided by n log. Here in the question, E cell value is given, E naught cell value is asked. Got it? Now we found what is the value of n. So here what is left out is to find what is Q value. We need to write the Q value for the given net reaction, right? So these two are my product. Here I have C, before that I have number 3, so I can raise this number 3 to the power. Before AL plus 3, I have number 2 that has to be raised to its power. And then what are the reactants I have? Reactants have to be written in the denominator. Here I have Al, before Al I have number 2, so Al power 2, copper plus 2. Before that I have number 3, copper plus 2 power 3. Usually students often forget to write the powers. Please be very careful, this step is important. Here I have copper and aluminum is in solid state. So for solid, value is 1. So if you write 1, cube is 1, 1 square is also 1. So what I have to write? The concentration of aluminum plus 3 square divided by concentration of plus 2 cube. So I need to substitute those values. Where do I get it? So here you can see concentration of Al plus 3 is 0.01. So that way I have entered. Denominator, I have copper plus 2, value is 0.0. Only the powers are changing. So how I can simplify this? Very simple. Write it in 10 powers. I have the decimal place here. I have to move the decimal place towards right side. I'm moving 2 places. So 10 power minus 2. Don't forget to write the powers. Here I have power 2. Here I have power 3. Now what should I do? I need to multiply these two terms, right? So 10 power minus 4 divided by 10 power minus 6. Now, how can we simplify 10 power minus 4 into, when this 10 power minus 6, I'm going to bring it to this side. So what will happen? The sign I have to change. So what I will be getting is 10 power 2. 10 power 2, nothing but 100. This is how I am obtaining the value 100. Got it? Okay. So now what should I do? I have to substitute values in Nernst equation. E cell value is 1.98. E naught cell value, you don't know. Number of electrons involved here is 6. Instead of q, I'm going to write 100. Let's now simplify log 100. So log 100 can be written as 10 power 2. 100 can be written as 10 power 2. This 2 can be brought from 2 into log 10. You know the value of log 10. So 2 into 1. 2 into 1 is 2. So log 100 value is 2. So instead of log 100, I can write 2. When you multiply these two numbers, you will be getting 0.1182 divided by 6, you will get 0.0197. So I need to find the E naught cell value. So what I'm going to do is I'm going to swap, I'm going to bring this term to the other side. Minus, when it's brought to the other side, it would become plus. So when I add it, I will be getting 9.9997. This can be approximately written as 2 volt. I hope you understand. Come to the next question. Zinc chloride is dipped in 0.01 molar solution of zinc sulfate when temperature is at 298 Kelvin. Calculate the electric potential of the zinc. Got it? So here, first thing you should know whether this zinc pod is acting as anode or cathode. To find out this, you have to look at this value. For zinc plus 2 to get converted to zinc minus 0.76 volt, which means that it doesn't want to get reduced to zinc. So it is acting as N. So zinc, after losing 2 electrons, it forms zinc plus 2. Now for this reaction, I'm going to write the Nernst equation. Nernst equation outright, E cell is equal to E naught cell minus 0.0591 divided by N log. Here I have what product here we have zinc plus 2 divided by zinc. Got it? So E naught cell value represent 0 minus 0.76, the standard electric potential for zinc, and the value of N to be 2, and the concentration of zinc plus 2 ion is 0.01 given the question. For solid zinc, this activity of the solid is considered to be 1. Now we are going to substitute all those values here. AMF of zinc is equal to minus 0.76 volt minus 0.0591 divided by 2 into log 0.01. Now let us discuss how to find the log value of 0.01. So here this 0.01, if I write in terms of 10, so since I am moving the decimal place towards right side, I'm writing minus, and then here 2 places I'm moving, so to power minus 2. So this power can be brought front, so I will be getting minus 2 into log 10. Log 10 value is 1, so minus 2 into 1 will become minus 2. So if I simplify log of 0.01, I will be getting minus 2. So instead of this, I'm going to write minus 2. And here the E naught cell value is 0.76 volt minus 0.0591. The number of electron involved here is 2. Then if I simplify this, I'll be getting minus 0.76 plus 0.0592. If I add it, I will be getting EMF of the cell is minus 0.7008.